For this lesson, we're going to learn about something called the Platonic solids. And if you look at this page, there's 5 different 3D shapes at the top. What makes the Platonic solids special versus just any other shape is all of their faces, all of their sides are the same size for all of these 5 shapes. And also, the way the angles meet up is the same, and the length of the edges is the same. So the first one's the tetrahedron. You have some triangles. Technically, this is also a triangular pyramid, except each of these sides is the same. You're very familiar with a cube. If you look at a cube, it's very symmetric. That's our second Platonic solid. The third one is called an octahedron. It's actually, if you look at it, has almost like there's a square in the middle, but that doesn't count as a side, and it's made up of these triangles. 2 more complex Platonic solids are the dodecahedron, which is right here, and the icosahedron, and we're going to be learning more about these. These are the only 5 possible ways to make shapes where the sides are all the same, the angles where they meet are all the same, and so on. There's no other way to make these shapes. So if we were in class, we'd be filling out a chart that's right here, just finding some of those qualities, and we're going to be doing that on a website. But before that, I'm just going to show you a couple of Escher's artworks where he included Platonic solids. The first example in his artwork is this one called Double Planetoid. And basically, even though there's a whole lot going on here, if we zoomed in, we'd see that this actually looks like it's a city with different buildings. This is 2 intersecting tetrahedrons, so 2 of those triangular type shapes that intersect to form this sort of, alien city. The next one is called stars. Let me move back up the page a little bit more. So when you look at stars here, basically this shape where these iguanas are in is 3 intersecting octahedron. So this is the octahedron. And if you look at this one that someone built out of paper, you can kind of see the 3 different ones. It's hard to tell because it's very complex what they're in. But then he also put different shapes. Some of them are Platonic solids. Some of them are just other interesting shapes as these little other stars around it. So the last one is waterfall. And the focus of waterfall is really this piece where it's called an impossible figure. And we'll be doing more of that later in the week. But also he threw in these 2 polyhedra. The one is the intersection of 3 cubes. So that's Platonic solids. The one on the left, that's right here. And then on the right, this isn't a Platonic solid, but it's really close. It's called the first stellation of a rhombic dodecahedron. And it actually, if you built this together, could tessellate 3D space, which means that if you had a room and you put these in it, you could fit them all together and there would be no space for air left. Kind of like what we do on a 2D figure when you guys did your tessellations last week. Since you're in the assignment, this would be the point where you click on this Platonic Solids website. Notice there are parts of this that are very difficult, and I put the answers here for them. So this information about the dodecahedron and the icosahedron, you can actually just type right in when you get there. So we're going to go over to the website now, which is right here. You had clicked on that link, and it's called Platonic Solids. You can read through this information. You should read through this information. Down here, you do not need to print, cut, and fold these nets. If you wanted to kind of build your own, that's totally fine. We actually would have built them with gumdrops and toothpicks if we were in class. The focus, though, after you do the reading, is to come down here to this section. And you can see you can switch up shapes, and they'll rotate. So these are your 5 Platonic solids. I'm actually going to look at the nets next. So for example, for the tetrahedron, here's the net. And if I play the video, remember a net is a flat thing that we can fold up into the shape, and we did that in Unit 6. So here they're showing just folding that up. So the tetrahedron is a pretty simple shape. We're going to fill out information about it now. Another thing to help you fill out the information, though, if you click over here, I'm going to pause the video, on number of faces, basically, I don't know, sort of helpful. It'll highlight the faces in green. If you want to see the vertices, it's going to put dots on each of those corners, okay? So 1, 2, 3, 4. I don't know what's going on with this dot in the middle. Maybe it's projecting this dot through it, but basically you can count the corners a little easier. Number of edges, it just kind of highlights the edges in green. So I don't know if that's super helpful. I think the net is the most helpful to answer the questions. We're going to do the first row of this table together. So for the tetrahedron, when I look at the net, I count 1, 2, 3, 4 faces. So you type 4. Now, what I usually do on this is I try to click on the next one. It's going to say, please check your answer first. You have to have your cursor in the space and press enter. If it jumps over to the next one, that means you get the right answer. So the vertices are the corners. So if I think about this net folding up, 1, 2, 3, and then these 3 other points would come to form another corner at the top. I can kind of count it here, 1, 2, 3, 4. If I want to look up at this picture, maybe 1, 2, 3, 4, maybe that's a way I could count it from this little picture. So I see there's 4 vertices. So I'm going to answer one wrong here. Let's say that I also think there's 4 edges. Okay, if I press 4 and enter, it'll say, sorry, that's incorrect. I can try again. I just click anywhere and I can try again. So here, if I look at the edges, and I'm going to use this little picture, there's 1, 2, 3 that form the bottom, right? And then there's 1, 2, 3 edges that go up the side. So I can also see that here, 1, 2, 3 already saw on the bottom, 1, 2, 3 on the sides. So edges might be the trickiest part of this. So there's 6 total. The type of faces, I just look at this picture, I can see that they're all triangles. And then the number of faces that meet at each vertex, okay? So if I look at this, and one other thing you can do with this part of it is you can send it off in different directions. Okay, so maybe that'll be helpful. I'm gonna play the video again. If I look at each vertex, like right here, I see that these 2 sides and the bottom all meet at this point. And part of that symmetry is every single vertex will have the same answer. So there are 3 faces here meeting at each vertex. So it says, good, the tetrahedron information row is completed. So I leave to you the last 4 to do, just with a reminder that in my directions, you can look up the dodecahedron has 20 vertices and 30 edges, and then also the information about the icosahedron. So when you get here, you can just type in those numbers for these 2. I don't expect you to figure that out. What you're going to do when you're done with this, once you fill in the whole table correctly, it's going to give you a congratulations, you can go on to the next step. I want you to take a picture with your phone. If you're working on a phone, you can have someone else in your house maybe take a picture with their phone and send it to you. I want you to take a picture of that message that says you finished. I'd also like you to try to get your face in it, just so I know you're not sending someone else's picture. So just try to get some sort of identifying information that I can tell it's you. If you want to hold a piece of paper up next to it with your name on it, anything that this is your work, and you're going to take that picture, attach it in Schoology, and then turn it in. I also have videos in the assignment showing that.